Okay, so let's remember, when you're graphing an inequality, any inequality, whether it's on number line or a number plane, okay, you get your boundaries by taking the inequality and just making it equals, right? Okay, so our boundary will look like this. And this hopefully is a graph, a function that you're very familiar with, right? It looks like so. Okay. And by the way, this has a name. It's called a hyperbola. And its plural is hyperbolae, however you pronounce it. Not to be confused with the method, sorry, not method, the technique from English of saying, you know, I ate 10 horses, you know, that kind of thing. So English, maths, right? Anyway, here's my graph, okay? Now, I'm going to include my asymptotes in here, right? Because these asymptotes, they define the boundaries. Okay, so I need to have them in. Okay, so here's y equals 0, here's x equals 0, and here's our boundaries. Okay. Now, I think we mentioned before when we were talking about functions, a particular category of function, which is ones which have discontinuities. Discontinuities. Do you remember that? Really important word, right? This graph has a discontinuity. So another way of saying it is it has two branches, right? There's the right-hand branch and the left-hand branch. Now, because of these, the duality of it, right? Or if there were 3 branches or 4, right? Each branch has its own set of rules for its inequality. So when we test a point, testing one point will not do. You've got to test, well, one for each branch. Okay, so how does this work? Let's think about a point. In this case, unfortunately we can't print the origin because it makes your boundary undefined, right? Or your inequality, right? So let's pick a point like, say, 1, 0. There, okay? Test 1, 0. Okay. As we put it in, we get we get 0 is greater than or equal to 1 over 1. Is this true? Let me make it more obvious. Is this true? Yeah, think hard, okay? So seeing as this is not true, this point is not in the region I want to shade, okay? So then you got to look carefully, all right? The way these inequalities work, right? They're greater than or lesser than. That means above or below, right? So instead of being, it's better to think about above or below than left or right. Left or right will confuse you. This is below, and it's not part of the region. Okay, so therefore I want above. Okay, so I'll get my color and I'll shade it. Okay, so there's above, right? Now when I have a look at the other branch, right, this is just one branch, okay? I've got to test another point, which is either above or below the other branch. Does that make sense? So that's why this point relates to this branch. I need to pick another one, like say, -1, 0, which is over there. Okay. So when I test this one, -1, 0, I get 0 is greater than 1 over -1. Is it true? Yes. So this point is in the region, right? Now because it just deals with the left-hand branch, right? That's why when I shade this, like so, keep going. The important thing to get is that it doesn't cross the y-axis. You see that? It stops because there's a discontinuity, right? There's a discontinuity. It doesn't break over and like take over this region here. We know it can't because we just tested that point and it's not in the region. It doesn't satisfy the inequality. Okay, does that make sense? So, when you're working out, okay, where are my boundaries here? When you've got discontinuities, you just got to be more careful. For each branch, test the point. Test it above or below. And then you'll know where you are. Okay?
Why are the lines dotted?
Okay, why are the lines dotted? So I always start off drawing my, my boundaries dotted because if I've got one or more, right, I'm not sure which parts of it will be okay and which parts won't. Now, probably it's true, I mean, I've only got one here. Okay, but I default to putting them as dotted because then the parts that I want to be filled, I can fill, and I don't have to rub out more. Okay, but as you point out, since that's the only inequality that I'm interested in, I do include the boundary. I just want to show you, it's over here, one more tricky example, which is not on your sheet, which is a semicircle.
That's mine.
Sorry. Let's go. Oh no, this is wrong. Sorry. Start again. Y equals 1 plus. Square. Okay. Sorry, I confused myself and I drew a circle the first time. Alright. This inequality, hopefully you can recognize, will be a semicircle, okay? Because you've got your square root there and there's a square underneath and so on, okay? So, what can I deal with this? Wait, hold on. Do I need that here? 1 plus. I think that's okay. We'll find out in a second, okay, as I expand it. Because it's a semicircle, right, I know it's going to be half of a circle. So, let's just keep this in mind. I'll write on the top for me. Okay, it's a semicircle. And I wonder if you can remember, you remember when we were dealing with semicircles, there are 4 kinds of semicircles, right? There's the top one, there's the bottom one, left and right. I don't say it yet, but just think about, well, okay, which one is this, all right? The reason why you have to think about it now is because I'm about to take the boundary, square out everything. When you square it, you lose which side it is, right? You don't know which one it is, you just get the whole circle, okay? So keep that in mind for now. Let's take the boundary and deal with the boundary. The boundary will be y equals 1 plus the square root of 1 minus x minus 1 all squared. Okay? So if I want to find out what circle this came from, right? I want to get it back into general form. Yeah? So I'll kick this minus 1, this 1 over here so it becomes a minus 1. Okay? That leaves me with the square root. Okay? Now I can square, so I've got y minus 1 all squared and that disappears. Okay. And then I bring my x minus 1 squared over the other side. And now I can recognize the features of this, right? Okay. I can now read off, because it's in general form, right? I can say the center of this circle is at 1, 1. And its radius is also equal to 1. That's convenient, isn't it? Alright. So now I can start to draw this. I can say my center will be 1, 1 up here. Now, did you work out? Is it the top, or the bottom, or the left, or the right? It's the top. How do you know? How do you know? Yeah, Richard.
Because it's y equals something, it's to do with up and down, because it's a square root, it has to be up there, because it has to be plus.
Okay, so seeing as this is plus square root, right? You're going to go from 1, think about it in this way, right? 1 will be the lowest value you can get, right? Because this square root thing, the smallest that you can get is 0, right? It can't go negative. So I'm going to go with 1 and up, right? And since the center is 1, I can't, and I'm going 1 and up, I can't get the bottom of the circle, okay? So, good logic, good. Let's draw this. What does the semicircle look like? It's dotted, right? Okay, there's the semicircle. Now before I said, a more intuitive way of thinking about circles and the inequalities they give you, right, is that you're either inside the circle or outside the circle, right? Inside or outside, okay? And that works when you've got the whole circle, right? Because it's a sort of a closed system, if you like, so you're either in or out, okay? But if you think about the semicircle, right? Well, let's test a point, shall we? And we'll see where we're going. Let's test the center, because that's nice and easy, okay? 1, 1. When you put it in, over there, okay? Test 1, 1, okay? what's going to happen? I'll have 1 on the left-hand side, it's less than 1, plus the square root of 1 minus 0 squared. Right? So you've got 1 is less than 1 plus the square root of 1. So 1 is less than 2. Looks good, yeah? So the center is in. If I just take that part inside the semicircle, okay, just like we were inside the circle, right? Like so. Okay. We've actually missed a whole bunch, a whole big part of the region, because remember how I was trying to draw your attention here, right, to the fact that really, rather than left or right, it's about up or down, right? Up or down. So that's why this goes all the way up, all the way up. It's exactly the same deal here, right? So you've got this weird looking arch, right? And it's above or below, not inside, outside, okay? So that's a bit confusing. When you've got a circle, it's that. When you've got a semicircle, because it's opened out, right? Let's test a point, like say, what's that, 1, 0, okay? This x value affects the right-hand side, right? So I'm going to get 2 on the right-hand side just like I got before. And on the left-hand side, I just have y. So I'll have 0 is less than 2. Does that work? Sure does, right? So this part, even though it's not inside the semicircle, is a part of it. You can keep on testing. I'm not above, I'm below, and I'm all of below, okay? So it keeps on going. Now, gotta be careful, right? I suppose we don't really think about this as discontinuous because it's not like there's a break, right? But this semicircle doesn't exist everywhere. So what happens to values like over here and over here? What do you think? Maybe I should ask this. Are they included or not? They're not included, but why not? It is only underneath here. So actually, I'm going to have to introduce a new boundary in here, here and here. Okay, so I guess this boundary would be x equals 2, right? And this one would be x equals 0, of course. But why can't I go outside? What happens if I go outside? Put in values like x equals 3 or 4 or 5. What's going on? You put a value in and you'll see what happens, right? I'm going to get 1 minus, and then this thing will start growing in size. Right? Is that what yeah? So I'm going to get negative values under the square root, okay? Now later on you'll see, negative values under the square root, they have a meaning, but not on this graph, okay? We're only interested in the real numbers, not the imaginary ones, okay? Therefore, make sure you catch the whole thing, okay? It goes all the way down, and of course if I flipped this inequality and said greater than, okay, it'll be all the ones above. All right. Now I wonder if you've noticed the pattern here, or maybe this is the way you thought about it from the beginning. If you've got an inequality which has y on one side on its own, okay, y on one side on its own. If you're greater than, you're above. Simple as that. If you're less than, you're below. Now, sometimes people get confused by that and they can't remember which is why we encourage you to test the point, because testing a point is foolproof, okay? And you can know with certainty and not be like, which one was it? Yeah?
Do you just need to label a point on the boundary on the axis, or do you have to actually label x equal to and x equal 0? And does the boundary go the whole way, or do you just stop?
Yeah, okay. I think it's safer, probably, to always label it as an equation. The reason being, all the other boundaries that I have will always be equations, right? So this is 1 plus square root of 1 minus, right? So I feel like it's kind of weird to have one rule for one boundary and a different rule for the others. Because it is a vertical line, which is sort of a special case, I think you could probably get away with it to say 2, right? But, I mean, on my graph I draw that. Okay. Do you draw the whole thing? I put it on because that line x equals 2 does actually go on forever. It's only relevant here, but the line itself is, So I don't think it matters that much, to be honest. But there's your graph.